Hi folks, and welcome to another video from British Columbia Institute of Technology Teacher Education Program, TTED, Material Science and Structures course. Today we're going to be taking a look at designing a truss. And our truss is going to be made with bamboo barbecue skewers held together with 3D printed nodes. And this truss is holding a 10 Newton or 1 kilo load, but your truss will be designed, in this case, to hold a 20 Newton load at a cantilever distance of 1 meter from the nearest support. And you're going to have to build it using the barbecue skewers that we have in class and 3D printed nodes, all holding everything together with hot glue. We're going to start our process by learning a little bit about truss analysis. And we've got our nifty little board set up right here so we can analyze various loads and structures in different directions. And somehow when you pull that weight, it always returns to where it belongs. And you can do some analysis to take a look at how those forces are distributed in a truss. Little bearings up in the top corner. Groove bearings is what you want. Make for a kind of neat structure right there. Once you understand how that's working, you're going to be able to take it over to this really cool program called Truss Me. And you're going to be able to come into Truss Me and you're going to be able to set up a design for your truss to say, okay, what forces are going to be distributed where. And that's going to be really important because when you can take a look at what forces are being distributed at different places, well, we're going to spend some time and we're going to get to know the properties of our bamboo barbecue skewers. There's actually some research papers suggesting that the elastic modulus of a bamboo barbecue skewer is pretty close to 10 gigapascals. I'm finding a number kind of closer to 8 works for myself, but through a bunch of testing, you're going to be able to develop your own number and see how close that comes to the predicted numbers. We've got a couple of different types of tests that we can do. We're going to do a tensile test to make sure that the hot glue that holds our bamboo barbecue skewers together is going to be strong enough to support the tensile loads that we place on the truss. You're going to do that by rigging up a bamboo barbecue skewer with a couple of end nodes, placing a scale on the end, and pulling until it falls apart. You can see we're up to 40 newtons there already. And well, anyway, your tests will be your tests. We're also going to test the compressive properties of our bamboo barbecue skewer by placing in a drill press, taking a little assembly like this, putting a scale on the bottom of the drill press, putting a bolt into the drill press instead of a drill bit, and just applying force on the scale until we see at what force members buckle when they're at different lengths. And you're going to generate a table of data that looks something like this and match it to the predicted behavior theories that a bamboo barbecue skewer should be following using compression buckling formula. We're also going to double check our elastic modulus by doing a 3-point bend test. And as you can see from the 3-point bend test, that includes the elastic modulus. So if we take the equipment right here, I've got this set up so that there is a 1 centimeter or 10 millimeter deflection from the center right here, and I've measured this out. I know the length of my skewer right here, so if I push down on the middle of it right here and hold it, you can see that that's taking 4.2 newtons of force to deflect a piece of known length, a known distance, and you can punch those numbers back into the 3-point bend test to try and come up with a good elastic modulus. Don't do it with just one test. You can then, of course, cross-reference that to your beam bending formulas where you've got some data on what the compressive buckling formula would suggest that the elastic modulus is. You can also do this for a laser cut truss, and you can do this with hardboard that you cut right off the laser. That's how we've done it for the last couple of years, but we wanted to go a bit bigger this year, and so we have bamboo barbecue skewers held together by 3D printed nodes. And over the next couple of videos, I'm going to show you how to take the data that you've accumulated, create a design, and put it together into trussme.com. Thank you, Norbert. You have really cool software and you share it with the world. That's very kind. And it's really cool. So awesome. This is the nicest online truss calculator that I've seen in a long time. And then we're going to take it and we're going to model the entire truss in Fusion 360. And in Fusion 360, we are going to run a structural buckling simulation, and we're going to see where under 20 newtons of load, the first place that your truss is likely to buckle will be. And that should give you an idea, an estimate on how strong your truss is going to be and how heavy your truss is going to be. And again, really the quality of your analysis here is going to be very dependent on the quality of the data that you've achieved by doing the tests in advance. So you're going to put it all together. You're then going to use Fusion 360 to create the 3D printed nodes. And then working with a partner, you're going to come together and you're going to assemble your truss, hopefully doing a straighter, nicer job than I did on my kitchen table one night. You're going to put it together. It's going to be braced. And you're going to put your load onto the end of it. And it's going to support that load for 30 seconds. All right, let's get started on building our bamboo barbecue skewer truss with 3D printed nodes.